Hello mathematics lovers. Today I want us to dive deeper into statistics. I want us to consider the subject of hypothesis testing using the t-test. In our previous videos on statistics, we considered stuff like the mean, standard deviation, standard error, error margin, and confidence interval. So, what is hypothesis testing? Another concept that we are going to examine in this video is the concept of the one-tail or two-tail test. It was mentioned briefly in my last video. So what exactly is one-tail or two-tail, and how do we know if we are to use a one-tail or two-tail? How do we know when to use the t-test or when to use the z-test? All of this will be covered in this video. On the screen, I have a question. The government recommended pump price of PMS is 600 naira per liter. Dealers are free to sell at a discount depending on location and other logistics expenses. A researcher believes that dealers are shortchanging the masses by selling above the government recommended pump price. The researcher experimented by buying PMS from 5 different fuel stations with the following results. So these are the different prices, as you can see. So A, conduct a suitable hypothesis test. B, calculate the sample mean and standard deviation. Then C, at a 5% level, confirm whether there is evidence to believe the researcher's claim that PMS dealers are shortchanging the public. Alright, so the A part of the question says we should conduct a suitable hypothesis test. In statistics, we have what is called the null hypothesis and the alternative hypothesis. The null hypothesis is, as you can see on the screen, it's usually written H0, while the alternative hypothesis can be written as H1 or HA. Whichever notation you choose to use is all acceptable. So what is the null hypothesis? Null hypothesis is simply the generally held view, the accepted standard, the current norm, what is generally accepted by everybody, the claim that is the traditional view. That is what is called the null hypothesis. While a researcher might come up and say, no, this thing that everybody believes, this traditional view is wrong. I have evidence to prove that that view is wrong. So that is the alternative hypothesis that the researcher wants to prove. So how is it written? In this question, the first part of the question says the government recommended pump price of PMS is 600 naira per liter, meaning that it is generally accepted that PMS, we call it petrol in Nigeria. Anyway, the real name is PMS, Premium Motor Spirit, that a PMS should be 600 naira per liter. So this is how it is written. Mu equals 600. So that is the null hypothesis. But this researcher says no, that he or she believes that PMS is selling above 600 naira per liter. So in the alternative hypothesis, the researcher is saying that mu is greater than 600. And that's it. We have finished stating the hypothesis. Either mu is equal to 600 on the null, or mu is greater than 600. So the B part of this question says we should calculate the mean and the standard deviation. Of course, if you watch my previous videos, these are very easy. The mean is the sum of all the results of the sample that is obtained by the researcher. You sum them up and you divide it by the number of samples. And if you do that, you will discover that the mean is 609. The next is the standard deviation. this is the formula for the standard deviation. You can watch my previous videos. By the way, we are dealing with a sample, not the entire population. So this is a sample standard deviation, and for that we use n-1. I hope we can still remember from my previous video. And to expand this n-1, since the mean is 609.2, then the standard deviation will simply be 550 minus 609.2 squared. The last sample he collected is 601 minus 609.2, and then you square it. Everything divided by n-1, which is 5 minus 1, and then we square. We take the square root of everything. That gives us the standard deviation. So if you work that out with your calculator, you have something like value of standard deviation giving us something like 55.23. So we move on. The C part of the question says that at a 5% significance level, we are going to conduct either a z-test or a t-test. So how do we know when to use a z-test or a t-test? Well, you're using a z-test if the sample size is greater than 30 and the population variance is known, or you use a t-test if the sample size is less than 30 and the variance is not given. So in this case, the samples are just 5 that the researcher collected. So it is very clear we are using a t-test and not a z-test. So we strike off the z-test. So we are using a t-test, and this is the t distribution table. It's going to be very faint, but I'll sure explain to you. So for us to conduct the t-test, we need a significance level. They said it's at 5%, so that's at 0.05. Alpha is going to be 0.05. And here is our normal distribution curve. The next question is this a one-tail or two-tail scenario? Remember that when we were doing our hypothesis testing, the researcher claimed that mu is generally greater than 600. He did not say it could be greater or less than 600. He generally said it could be greater than 600. So this is an indication that we're using a one-tail scenario. So because it's a one-tail scenario, we have shaded this portion, and if you could recall from my last video, this portion of the bell shape or the normal distribution curve is called the rejection region. If any values fall inside the rejection region, then we draw a conclusion from that. So the next thing is our critical value, and this critical value here, we are going to read it from the t distribution table. So what is the critical value? Before we go into that, we have the degrees of freedom. Degree of freedom from our last video is n-4, which is 5, n-1 rather, which is 5 minus 1, and that gives us 4. So with this, we go to the t distribution table. This is the column for the degree of freedom, where this is the column for alpha. Our alpha is 0.05. I don't know if you can see it on the screen, but I'm going to do my best. And the degree of freedom is 4. So that gives us a value where they meet. That gives us a value of 2.1318. The critical value here is 2.1318. So this region is the alpha, which is 0.05, and this region, the acceptance region, is 0.95. Our mean is somewhere here, because the mean has to be in the middle of that bell curve. Now that we have got our critical value, the next is the calculated t value. So two things: you get a critical value from the t-distribution table, and then the next is the calculated t value. Watch how we're going to do that. So on the screen, you'll have a formula for calculating the t value, or the second t value, or the calculated t value, t calc. And what is x bar? That's the sample mean, is what is called the x bar. Now the hypothesized mean, the generally accepted view, is what is called u here. So the sample mean, let's state what we know already. The sample mean was 609.2. Our n equals 5. We'll just plug this into this formula. So that will give us, this equals 609.2 divided by square root of 5. So I've simplified the solution here. If you work this out, you will discover that our t calc equals 0.3723. Alright, so we've got everything that we need to either accept or disprove the researcher's claim. We said that t calc equals 0.3723. Now this is the zero. This is zero region, and the critical value is 2.1318. So t calc is going to fall somewhere here. That's 0.3723. Now, as you can clearly see, the calculated t value did not fall within the rejection region. So we can now come to our conclusion. So here it is. The conclusion is that t calc falls outside the rejection region, and what that tells us is that we fail to reject H naught. We fail to reject H naught. Remember, H naught is 600, while H1 should be greater than 600. But from what we have solved, we fail to reject H naught, meaning there is not enough statistical evidence to support the researcher's claim that dealers are shortchanging the masses within a 95% significance level. Now, this is just a hypothesized question, but what could have happened? Because obviously there were some figures that supported the researcher's claim, some of the sample results. But what could have happened is that the researcher may need to gather more evidence to support his claim. In the first case, just 5 samples may not be enough for the researcher to be able to prove what he wants to prove. Meaning, we still hold on to the traditional accepted view that the PMS, the average PMS price is still hovering around 600. We do not have enough evidence to prove that dealers on a whole, on a general, even if some are shortchanging the masses, not all of them are shortchanging the masses. So this is all about hypothesis testing. I hope you enjoyed this video. Please share this video. Please and please and please, it is important that you comment on this video so that others can come in contact with this video. I will see you in the next video. Thanks and bye for now.